In my opinion, one of the most irritating problems you can run into on a 3D printer is called heat creep, and today's video is going to be all about it. Hello everyone, Chris here, and yes, heat creep is one of those issues that I've talked about over the years in many different videos, but never really dedicated a video on how to fix it. And that's because it's not always the easiest problem to diagnose or catch on your 3D printer at a great time for me to make content on it. But I have a great case here today, and I'm going to show you all the ins and outs. Now, I don't want to waste any time here at the head of the video explaining what it is. We're going to jump right into it. But nowadays, 3D printer manufacturers are actually starting to put in sensors and different types of thermocouples and thermistors to be able to detect this issue. So it might be a thing of the past someday, but not quite yet. So let's jump into it. We'll talk all about it, and we'll get our Prusa Mark II here up and running again. So before we jump into fixing or talking about what heat creep is, how do you know you have it? Well, in my case, I came down one morning and I had about this much of my Voron parts printed. So it stopped relatively early in the print process, and you can see that some of the layers here are very sparse. So very close to the beginning of the print, there was some sort of jam that kept the filament from proceeding and completing the print. And this type of thing, when the part looks good at the beginning, the first layers look great, but the part doesn't complete, that can lead to a couple of different issues that we might have to solve, but heat creep is going to be one of them. Now, if you're lucky enough to see your 3D printer doing this kind of thing mid-print, you're close to the printer, you're paying attention, this is what it's going to look like. Now, it's not kicking out any filament. Again, this filament has probably already been ground through because of the failed print, but you should be able to hear the extruder tick, because it's trying to grind that filament and push it through when it can't. So if you're seeing this, but you haven't seen any problems with the print as of yet, you're probably headed towards heat creep. And it's usually not at the beginning of the print. It usually lets you get a few layers in before this starts to happen. So what is heat creep and why does it happen? Here we have a sliced 3D printed model of an E3D V6. At one time, a very common hot end, pretty much the gold standard for many years. But this just makes it easier for me to show you what's going on. You have the heat sink, you have your brake or throat, the cold side area, then the actual brake part, and then you move down into the hot side, your heater block, and your nozzle. This would be a representation of an all-metal hot end. There are no PTFE parts down in the cold or hot zone. What happens in the heat creep scenario is when the hot part's down here, the heat starts to creep up past the brake. The brake is what's actually supposed to keep the cold side cold and the hot side hot. But in this condition, the heat sink can't wick enough heat away from this throat area. The heat goes up and then melts filament inside the throat here. If you're starting to get melted filament in this area, it's going to cause a jam. It can't push it through to get heated properly to come out the nozzle. That's why we call it heat creep. It's actually creeping back into the cold part. You have to keep these two sections separate. In a PTFE lined hot end, it's pretty much the same thing, and it can also happen in those designs. But in that scenario, like on a Creality machine, you would have a piece of PTFE tube right down to the nozzle. Now, you still have to have some sort of heat sink to keep this tube somewhat cool, because if the filament is molten, the heat creeps back into this tube, it's going to jam in this tube. But it's not near as easy to jam it in a PTFE lined hot end as it would be in an all metal. So it's going to be more common in an all metal style. And to help combat that, we have parts like this. This is a copperhead heat break from Slice Engineering, but you'll notice it's a couple of different pieces. These are pressed together. They do have copper in them in some of the pieces, but then a tube down through the center that's made from stainless steel. The copper and the stainless working together, you'll hear that called a bimetallic heat break. The stainless steel doesn't carry the heat as well as other types of metal would, and then the copper is very efficient to be able to pull that heat away if it does come back. So these can be a big help trying to alleviate heat creep. Or something like the Prusa Mark IV nozzle. You can see we have the brass nozzle, a stainless steel tube, and this copper collar all in one piece. The nozzle is screwed all the way into the heat block, but given this design, it's not going to be able to transfer heat up the stainless steel tube, melt that filament past this copper, and be able to cause a jam. So this is another solution we're starting to see a lot of. And all the new different designs coming out are great. That's going to help us going forward. But it is completely possible to get an all-metal hot end to print PLA just fine. You just have to know the steps and what to look for if you need to fix a situation like heat creep. So there's a couple key things you're going to want to look at. So start with the simple things first. Pull the nozzle out and make sure it's not clogged. Now if you did have a clogged nozzle, it's probably going to be causing you problems all the time, not just after first few layers. A classic sign of heat creep, it'll let you get a few layers in and then it'll start showing up because that heat has now risen back into the cold side of the hot end. But again, simple first. Nozzles are fairly inexpensive, just swap it out and give it a try. The next thing you're going to want to check is your filament. A lot of us, including me, use very inexpensive filament, and the consistency might not be that great. If your filament gets larger in diameter and you have a very constrained hot end setup, it's going to cause a jam like we're talking about here. And that's a very easy fix. Swap out to another filament, see if it works. Just rule that out first before you go pulling things apart. It's really easy just to grab a set of calipers, measure the filament to see that it's in spec. As long as it's close to 1.75, you're probably perfectly fine. But I have seen some filament that ballooned all the way out to 2mm, and that is definitely going to cause a problem. The next big thing that you're going to want to look out for if you're trying to diagnose heat creep is the hot end fan. One, make sure that it's still spinning at all. Most 3D printers now are going to be able to tell if the fan isn't spinning, and they'll probably stop and give you an error. But you also need to make sure that fan is adequate. You want to make sure it can push enough air based on your hot end manufacturer specs, and they're all going to be just a bit different. Now this printer is a Prusa Mark 2.5. So it has some of the upgraded Mark III parts on it. One of those being the Noctua fan. Now these fans are known for being very quiet, but there's also been some debate that these aren't adequate enough to cool down a hot end like the V6. And if you remember the original V6, it actually had a fan directly mounted on the heatsink. There is a little bit of separation here in this design. Is it adequate enough for this hot end? That's up for debate. But what I do know is it's very possible to get this design to work if you follow the steps correctly. I use these kind of designs all the time, and they work great. And it's definitely worth mentioning the old school V6 design. Traditionally, you would have one of these collars on it that went right on the heatsink, and then you'd have a 30-30 fan. So that little fan dedicated right here, right next to the heatsink, is definitely going to be able to kick out much more air and cool this off more efficiently than the design we're dealing with today. It's not a deal breaker, it's just something to note. This is originally how they were supposed to work. So before you start taking your 3D printer apart, let's go over it one more time. Check the nozzle, check the diameter of your filament, make sure it's small enough to go through your hot end, as well as make sure your hot end fan is operating properly. Now, I know for a fact that this printer is suffering from heat creep. Let's go ahead and dive into it, and we'll try to get it all fixed up. First thing, I'm going to heat the nozzle up to about 260, and we'll get that nozzle pull out of there. While it's heating up, I'm going to go ahead and remove these zip ties, just so we have a little room for our wires. We're going to have to pull them out just a bit. We don't want them to stay constrained and cause any issues damaging the wire. After the nozzle's up to temp, I usually let it sit there for a couple of minutes, but then we can just use the pliers, pull the sock off, if you have one. Be very careful, it is very hot. On a V6, you want to take your pliers and hold the block, and then use your nozzle tool or wrench to back the nozzle out. We pull the nozzle out now, one, because we want to inspect it first, because that would be the easiest fix. But two, you have to back that nozzle out hot on this hot end design. Now we'll go ahead and reset the printer to start cooling it down, and then we can start taking it apart. Now the best thing to do would be probably to pull the heater and the thermistor out of the block, but on a lot of these blocks, that's pretty hard to do without stripping a grub screw. You can get this job done without removing those on the V6 design. Not every hot end this is going to work, but we can get it done here today. On the Mark II, Mark III designs, I just pull these two front screws, one over there, pull the screw that goes into the motor that holds the idler door, and then the one over here on the other side that goes into the motor. And then I just go ahead and pull the idler door screw, the one that's spring-loaded, just to make sure there's nothing going on inside that idler that would prevent the filament from extruding. You can pull the door off. Go ahead and check your gears. On the Prusa design, we're also going to pull these front two hot end fan screws to release that front cover. That'll let the front extruder cover hang down. Just be careful of your wires. You don't want them getting close to that hot block. Make sure it's been cooled down already. And just as kind of an added bonus, you can see how that's eaten through that filament in there. So we definitely have a problem. But with all the screws we've taken loose, you should be able to just go ahead and slide the extruder motor off. Be careful with all your wires. You don't want to damage anything. And there's the hot end assembly. You can definitely see that mine has some miles on it. This is the original hot end from this printer, but I'm just going to go ahead and pull it out. Now, even before you start taking things apart, sometimes you can get lucky. Again, make sure it's cool, but pull down on this retainer and try to get the PTFE tube out. Sometimes the filament will come out complete. It's probably going to be jammed in there, inside the PTFE, but sometimes this can save you. But no such luck today. It's really stuck. The end of this PTFE goes down in the very top part of the throat, somewhere in here. So now we need to pull the heatsink off. Since it's loose, I'm just going to grab the block with a set of pliers. Remember, we are still hooked up to our heater and thermistor, but the nozzle's out, so it's not torqued down inside the block. You should just be able to pack this out by hand. And there we go. Heatsink and throat all in one piece. And then you can pull the barrel or throat out of the heatsink. Now I found with heat creep, if you have this kind of condition, the filament is jammed in here really tight. That barrel can be really hard to back out. So what I would do if I can't back it out is apply some heat. I wouldn't go full on with your torch, but maybe get your heat gun out just enough to soften up the filament that's in there so you can pull it apart. Once you've got enough heat on it to loosen up that filament, you can take a set of pliers, hold it, and then back that throat out. It's best not to use pliers on these threads. You don't want to mess them up, but get a rag or something to protect you from the heat, and then go ahead and twist that out. So it's out. You can see it's still clinging on to that filament that was jammed in there because of that heat creep. Now you can just continue to heat it up and clean it out with your heat gun to get rid of all that extra filament. And in this design, it's also a great time to replace your PTFE tube. These do wear out over time. Be cautious on the length of these. Not all Prusa machines, not all machines are going to have the same length. Different Prusa machines have a different length, so look it up in the assembly manual to get the right length before you replace it. And the throat has to be absolutely clean. Either swap it out or try to heat it up and clean it out with some sort of push rod. A lot of printers come with these rods. They're anywhere from 1.5 to 1.9 millimeter, but they do a great job at cleaning things out like this. But we can't have any excess filament inside here, or it's just going to cause the same problem. These have to be absolutely clean. Now you can take a torch to these to try to clean them out. Just be really careful. You don't want to get it too hot. So clean this out the best you can or swap it. We've got everything all cleaned up. I got the filament out. You can see straight through it. We're looking good. You can buy these small piano wire style rods. They're very inexpensive. These are great to help you clean things out if you have to do a lot of stuff like this. But now we're ready to go back together. So the best thing that you can do is just make sure everything is as clean as possible. We do have to use thermal compound inside here, but you want to make sure any of that old compound has been removed. I like to use these little straw brushes to get in there and clean up these threads. If you have a tap this size, that would be even better. Be very careful, but you can get in there and clean those up with a tap. That would be the best solution. Same way with the throat. If you're reusing it, make sure all the threads are very clean. We have to clean up all this thermal compound. You could use a die if you wanted to. I believe they're 7 millimeter. Just be really careful. you don't want to disrupt any of the existing threads. So just make sure you get it cleaned up as good as possible. So this segment was a bit of an afterthought, but at this point in this video, we've got everything cleaned up and we're ready to start putting things back together. But the question is, what actually caused this heat creep condition on this printer? Because it hadn't had any hardware failures, meaning the hot end fan, and these hot ends usually don't give me any problems. And I hadn't had any issues up to this point. And I have two ideas on this. I have seen this on E3D V6s when you disturb them, meaning you back the nozzle out and maybe you turn the heat block just a bit. That could disturb the barrel, and that heat compound they have on the barrel in between the heat sink could be less efficient, causing you problems. That's just a theory. But the second idea I have never printed with this printer inside an enclosure before now. And that's where it's been the last couple of months. I think maybe the increased temperature inside the enclosure and the design of the hot end, and I don't know what its current state was, meaning the last time it was put together, might have caused this heat creep issue to show up. So doing the procedure we're getting ready to do, putting thermal compound on it, getting it all back together how it should be, should resolve the issue going forward. But we're going to find out. So let's continue on. So after everything is cooled down and cleaned up, we're ready to go ahead and go back together. The key parts here being the heatsink and your throat. As designed to make all of this work, you do need thermal compound. I like to use this stuff from Slice Engineering. It's boron nitride paste. It comes in a little syringe. It just makes it easier to use. As well as these little foam Q-tip type things you can get on Amazon. You can get a bunch of them really cheap. It just helps you put it in the threads. On an E3D V6 design for your throat, you only want paste in the cold side of the threads. All this paste is doing is helping this heat transfer or wick away. If there were any warm sections, if there were any heat that comes past the break, the paste is going to be able to make that heat sink work even better. Even though this is the cold side, you are going to still get some heat there, and the heat sink has to be able to do its job as efficiently as possible. Remember when I was talking about that fan? The fan is there to keep the heatsink working very efficiently. So you want it to have an easy job. So use that paste. So I like to just put quite a bit on. Make sure you don't get any in the filament path. That can really cause a bad day. But just thread it into your heatsink, and then you can clean up the excess. You just want to make sure it gets in those threads really well. And on the V6 design, just hand tighten that on there. It's going to stop exactly where it needs to be. And then you can clean up all of this. Now for this video, I'm trying to show you how to reuse as much stuff as possible. A lot of this stuff, it makes sense to go ahead and replace it. But you don't want to always have to do that. Now you'll notice this heat block has a lot of wear on it. It's got a lot of filament. It needs to be cleaned up. I actually like to do the outer part of this after it's assembled. So we'll take a look at that here more in a second. The key here is make sure these threads are clean. I usually, again, like to heat these up with a heat gun, use my pliers to hold it, and then use a tap to clean out any filament that might have leaked out. Now that's not the only way to do it. You can heat these up, or again replace them, and kind of scrub them out with a brush. But if you're very careful and you don't alter any of the threads with that tap, this can be a great tool to clean these up. But now that everything's cleaned up, we're ready to go back together. So the nozzle is actually what holds that break in place. So from the bottom, again, we'll clean this up later, we'll just put our nozzle back. I did clean up the nozzle as well. And on the E3D design, you want to leave that sticking out. You don't want the nozzle flush to the heat block. Leave it out about 1 millimeter, because we're going to hot tighten this after the fact. And then your heat sink, you can kind of use it as a wrench to go ahead and put your throat back in the top of the block. And when you have it done correctly, you should barely be able to see the top of that last thread sticking out of the top of the heat block. That's how you know you have your nozzle in the right position. So that should be good enough. After we hot tighten the nozzle, everything will be locked in place. Again, you might want to consider replacing that PTFE that just helps feed the filament down inside there. Now we'll put everything back together. Now that everything's back together, you will want to let that thermal paste dry. You can either let it dry overnight, or just turn your printer on and heat the hot end up to about 90, just to let that paste dry for a little while. You don't want to exceed high temps until all the moisture has escaped from the paste, so it has a nice solid bond. So if you let it set at 90 for about 30 minutes, you should be good. You might trip your thermal sensor. It is going to time out on some printers, but reset it again. Just give it some time at a lower temp to help it dry out. So I set this one for 90. I did reset it because the timer's for 30 minutes, but I set it to 90 degrees for an hour just to be safe. Now, Slice Engineering does recommend using boron nitride paste on their hot ends on the hot side as well. So it's more important on that side than it would be what we're doing here, but it doesn't hurt anything to go ahead and do that. Now we're ready to go ahead and set it to about 260 so we can hot tighten that nozzle. We've been at 260 for a minute. I'm just going to grab it with pliers and torque it with my nozzle tool. Just mind your wires. You don't want to short them out. And that should be good. It is very important to get that nozzle snugged up against that brake. If you don't, you're going to have leaks. So double and triple check that. Now you can use a brass brush to clean off that hot block. Mine is pretty messy. I much prefer to do it while it's on the printer like this, under its own heat, than trying to heat it up outside. Now, you're not going to get it completely clean, but anything's going to help. But I do recommend turning the printer off while it's up to temp, and then clean it really quickly while it's still hot, rather than doing it with it on. These can short out your heater wires, and that could short out your board. So be very careful when you're cleaning off that block. All that's left is a silicone sock. If you want to put that back on, I like them, but that's up to you. And there we go. Now you should have just a little bit more information on heat creep, what it is, and how you can try to correct it. Of course, every 3D printer is going to be just a little bit different. The V6 was a very common hot end for a long time, so there's a lot of them out there, and hopefully this will get you up and running. But remember, no matter what hot end it is, try to find the manufacturer's specs on how they want you to set up their hot end. Like with this thermal compound, E3D recommends it, and on some printers it is completely necessary that you use that on different hot ends. So definitely check out all that information before you try to correct something like this. Also, one last tip that I can give you that's not very popular: if you're running PLA on an all-metal hot end, sometimes it likes to stick, but that shouldn't be the case. And if you want a really quick and dirty fix, try dipping the filament in some sort of plant-based oil. Vegetable oil works great. Don't oil your filament continuously, that's going to weaken your 3D print, but just put a little on the tip of the filament to season that break. Run a test print, and then you should be good from there. That's kind of a last-ditch effort, but it really can't hurt much. Just go ahead, give it a shot, run a test, and then if you don't like it, just don't do it again. It'll cook the rest of that oil out of there. So that is it for today. Hopefully you found at least a little tidbit in here that's going to be helpful. I'll see you really soon on the next one.